Hello guys, welcome back to my YouTube channel. So today we are going to solve day 12 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today we are going to solve problem number 2406. Divide intervals into minimum number of groups. Okay, so in this problem you are given a 2D integer array intervals where intervals of I is representing left and right points, right? And these left and right are inclusive. Okay, so we have to decide the intervals into one or more groups such that each interval is in exactly one group and no two intervals that are in the same group intersect each other. Okay, so we have to return the minimum number of groups you need to make. Two intervals intersect if there is at least one common number between them. So see this example here, two intervals are this 1 5 and 5 8, so they are intersecting, right? This 5 is common point, and here they said that it is an inclusive interval, right? Left to right all the numbers are inclusive, right? So here 5 and 5 are intersecting, so we can't add these two intervals in a single group. Okay, so that's the simple meaning of this one. So now see this example number 1. Okay, so here these are the intervals given to us, right? 5 to 10, 6 to 8, 1 to 5, 2 to 3, 1 to 10. Okay, so let's say first I want to add this in any group. Okay, so right now there is no group, so let's create one group and add this 1 to 5 in that one. Okay, I have added this 1 5. Now after that, let's say I want to add this 2 to 10. Okay, so 2 to 10, can I add this 2 3 in the same interval as this 1 5? No, because there are some numbers which are intersecting, right? So for this 2 3 I'm going to make a new group. Okay, so I have added this 2 3 in a new group. Let's say after 2 3 I want to add this 110. Okay, so 1 to 10, I can't place this 1 by 10 here in this because there are some numbers which are intersecting. I can't place this 110 in this one because there are some numbers intersecting. So for this 110 I'm going to create a new group. Right, now let's say after that I want to place 6 8, so I can place this 6 8 in the same group as 1 5, right? 1 to 5 and then 6 to 8. Okay, so I can place it. Okay, so 5 to 10, I can place this 5 to 10 here, not in group 1. I can't place because 5 to 10 here it is intersecting with this one, so I can't add, right? 5 to 10 I can place it here in 2 3. Okay, so 2 3 then 5 to 10, so I can place it here. So it can be proven that it is not possible to divide the intervals into fewer than 3 groups. Okay, so that is why output is 3. Okay, so I hope that you guys are clear with this explanation. Now how we are going to solve this problem? So first thing that we are going to do here, we are going to sort our intervals based on their left points. Okay, the starting points. So first this 1 by 5 will come. Okay, 1 by 5 will come first, and then after that 1 by 10 will come, right? Both have same starting point, so this is going to be order. Then after that 2 by 3 will come. Okay, then after this 2 by 3 5 by 10 will come. Okay, based on their starting point, right? The this value. Okay, 5 6 1 2 3, based on this I'm sorting. Okay, and then after 5 10 6 by 8 will come. Okay, so this is done. So first thing we have to do this. Okay, and then we have to create a one min heap. Okay, this is my min heap. Okay, so in this min heap I'm going to add the ending points, okay, of all these intervals. So let's say initially this is my interval. Okay, this is my interval initially. Okay, 1 5. So initially there is no group, so let's create one group. Let's say this group name is G0. Okay, so in this group I am adding this interval 1 to 5. Okay, let's say 1 to 5. So for this particular interval, the starting point is 1 and ending point is 5. Okay, this is right. So in this min heap I'm going to add the ending points, okay, for this group. So ending point for this group is group 0 is 5, so I'm going to add this. So this is min heap, so smaller value will always come to the top. Okay, so and I am adding the right points in this min heaps, okay, for all the groups, whatever the groups I have. Okay, then after that I'm going to check this interval. Okay, so in this interval 1 to 10, so I can't place this interval 1 to 10 in the same group as 1 to 5, right? So for this I have to create a new group, right? G1, let's say. So here 1 and 10. Okay, I can't place this 110 in same as 1 5 because there are some numbers which are intersecting. So now for this group G1 I am going to add this 10 here in the min heap, okay, for this new group. So here 10 is going to come here, right? because 10 is greater than 5. Okay, then after that I reach at this interval. Okay, so I can place this 2 3 in group 0. No, because there are some numbers which are intersecting. Can I place this 2 3 in group 1? No, because there are some numbers which are intersecting. So let's create new group G2. Okay, and in this add 2 and 3. Okay, so now this is the right point, right? So I have to add this 3 in my main heap because this is a new group, right? And 3 is going to come at the top because this is main heap. Okay, then after that I reaches at this point. Okay, I'm checking this interval 5 to 10. So here 5 to 10. Okay, so now what is going to happen? 5 to 10 I want to add. Okay, so 5 to 10 I can place this 5 to 10 here, right? After 2 3 I can place this 5 to 10 here in my group 2. I can't place 5 to 10 here because 5 is intersecting in group 0. Okay, I can place 5 to 10 here in group 1 because there are some numbers which are intersecting, but I can place this 5 by 10 in group 2, right? I don't need to create another group. Okay, so now I am adding this 5 to 10 in my group 2. So here what is the largest value here? Largest value here 10 na? Right? So now what I'm going to do here, I'm going to pop this 3, and in place of this 3 I'm going to add this 10. Okay, and 10 is going to come down. Okay, because this is main heap. Okay, this is done. So I hope that you guys are clear, because here see 5 G0. Okay, 5 is coming from G0, the ending point, okay, of this group. 10 is coming from, let's say, G1, the ending point of this group, and this 10 is coming from G2, the ending point of this group. Okay, so I can't place anything else. Okay, now after it 6 to 8. So 6 to 8. So here see at the top of my main heap, I will find this value directly. Okay, the at the top of my heap the ending point here is 5, and this 5 is less than the starting point of this interval 6. So I can add this 6 by 8 in my group 0. Okay, so I am have added this. Now from G0 what I have to do, I have to remove this 5, and in place of this 5 I have to add 8. 8 is going to come to the top because 8 is minimum. Okay, so see 1 5 6 8, 1 5 6 8, 2 3 5 10. Okay, 2 3 5 10 and 110. So in the end I have to just return the size of this main heap. So size of this main heap is 3, so that is why I am returning 3 here output. Okay, code is very simple for this problem. First let's sort this intervals array. So we are sorting, we are going to sort intervals, and here let's say there are two intervals a and b. So I have to sort them on basis of their starting point, right? The left point, a of 0 minus b of 0 I have to write. Okay, so this is positive, then a will come first, interval a will come first, and if it is negative then b interval is going to first come first. Okay, let's create the priority queue now. By default it is a main heap, so we don't need to do anything else. Let's iterate over all the intervals one by one. Int interval in my intervals. Okay, and here inside this just check one first thing, that my priority queue is not empty. Okay, so if it is not empty, then after that what we need to do, after that we need to check if the topmost element pq dot peak, topmost of element in from my priority queue, okay, this 5 is less than 6. Okay, so we are just comparing the topmost element from my main heap, okay, from my priority queue. Okay, if this value is less than the next interval starting point. Okay, so that simply means that we can add that interval in that particular group. Okay, that's the simple meaning of this one. Okay, if this condition is satisfied. Okay, so here I'm writing interval of 0. So if that is the case, that means that I can add that particular interval in the same group. Then for that particular group, old group, I have to remove the ending point, okay, from my priority queue. So here I'm just going to write pq dot poll. Okay, and every time for every interval, okay, what I was doing, I was adding that particular right point, right, the ending point in my priority queue. Okay, so here interval of 1, this is what I'm doing every time. Okay, this is done, and in the end we have to just return the pq dot size. That's it. Code is very simple, right? Just 12-13 lines, right? Now let's run it and see if there are any code issues. So let's see. So see, all the test cases has been accepted. Now let's submit it. So the time complexity of this problem is going to be of n log n. and it is due to this step. Okay, this time complexity is dominated by this step. Okay, so you can see the time complexity from here. So this time complexity is nothing but of and log n. Okay, so I hope that you guys are able to understand this problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.